In this tutorial we're going to import a ceiling fan and a wall dial to control the fan into the scene. We're then going to make our ceiling fan rotate and then make the dial on the wall control the rotation of the ceiling fan. We're then going to import a TV and use a movie file for its screen texture. We'll start by setting up the objects, first focusing on positioning and parenting. As you can see with this tutorial, we've already created a new group, Tutorial 5 Logic and Operators, and into that group I've imported the 4 objects needed for this tutorial. So the first of which is our fan base. So this is for the ceiling fan that's going to go in our room. And this is the base of the ceiling fan, so the bit that attaches to the ceiling. Next we have the blade, so that's just the blade for the ceiling fan. And after that we have our body for the switch, so that's just the main body which is going to attach to the wall. And then we have the fan switch itself, so this is just the rotary dial that's going to be on our switch body. So let's connect these up to the renderer in the start group. So just one by one link them up. And then basically what we need to do next is parent them, so each one of these has a correct relationship to the other component. So let's now unpack the motion of our fan base and the fan blade. Now basically we want to parent these so that our fan blade is always going to be parented to the fan base. So let's connect that link up there, and let's go to the animation section and have a look where they are. So you can see these are already correctly positioned. That's pretty much where we want them to be. And if we were to move our fan base around, you can see because we parented it, the blade can move around with it. So we can put this wherever we want in our room. Okay, great. So now that we've got this sorted, let's start having a look at the other objects. We've got the fan base switch and the body for that as well. So let's just go and unpack the motions for both of these. And again, we want to create a parent relationship here as well. So we want the switch to be parented to the body. So again, shortcut from the motion of the body, and we're taking that to the motion child link position of the switch itself. So if we now look for our walkthrough camera and look up to the ceiling, you can see the fan is correctly positioned. And if we look behind us over here, you can see that we have the dial on the wall. So everything's set up, the objects are in position. What we now need to do is create the logic so that we can turn the fan on and off. We'll now look at setting up the logic. So let's go back to the channel section and have a look at the rotation vector of our fan blade. So if we double click this envelope here, you can see as we move it up and down, the fan blades rotate. So this is the one we want to be operating on. So let's just close that down, and I'm actually going to delete this envelope from here. And now I'm going to drag in a new channel into the channel graph called the call on get child. Now what this channel enables you to do is basically you can create logic at any place you like within the channel graph. So normally you'll only be able to connect a value up to this vector because it'll only accept channels with a base type of value. With the call on get child channel, you can set its base type to anything you like. So you can see we have this list here. So if we set it to value, our call on get child now has a base type of value, which means we can now link it up to our rotation vector. Now the first child on here allows you to connect anything you like on here, so we can basically create some logic on this first child link position. On the second child link position, we can connect the value which we want our vector to use. So if we connect a value up here, drag one into the channel graph and connect it up to this second child link position, you can see as I change a different value in here, our fan is moving. So our rotation vector is using the value which we've connected to the second child link position here. Let's now make the fan rotate. So let's now drag a new template into the channel graph. So if we go to templates and then value operators, under variables we can get a loop relative value. Let's drag that in. Now basically the loop relative value channel, it takes a value and then that value will be used so basically determine the speed at which your value loops between the start value you specify here and the end value you specify here. So if we go to our channel list and get a value, drag it into the channel section here, and I'm going to replace the current rotation value with this here. Now if I give a value of say 0.1 in here, can you see our fan is now rotating? And what this channel is actually doing is it's looping between 0 and 100. You see, as soon as it gets to 100, it's reset back to 0, and it will continue to loop between your start value here at 0 and the end value 100, and the third value you specify here will basically determine how fast this looping occurs. So as I increase it, if I put this to 0.5 now, you can see now it's going 5 times quicker. So to start with, we need to specify a value which will be exactly the rotation of our fan, so one complete rotation. If we do less than that, what happens is the loop won't be correct, so it's going to suddenly start at 0, and you'll basically notice very prominent loop points. So we know that one complete turn is 2 pi, so let's put 6.28 in here. Now it's going to loop between 0 and 6.28, so we'll have a seamless loop. So you can see now as we've slowed it down, that's looping just fine. So we've now got our looping to work correctly. The next phase is to create some logic for the switch, which will determine how fast and how slow our fan will rotate at. So basically we'll be manipulating this value here by using our rotary dial. We'll now look at creating the interface, first focusing on detecting mouse collision. Let's now create some logic on the first child link position of our call on get child. So we'll use this logic for turning our switch on and off, and also for the movement of our dial. So let's drag in a channel caller into the channel graph, and let's just call this fan logic, and then we'll create 2 more channel callers branching out from here. So the first of which can be the first of this can be for the fan switch, and the second of which can be for the dial movement. So dial rotation logic. Okay, so let's start off with our fan switch logic here. Now the first thing we want to figure out is whether our user has their mouse over the fan switch or not. So to do that, we need a channel called the detect mouse collision. So if we can find that in here, detect mouse collision. Now this basically works by just connecting an object beneath this channel as a child, and then this will give a value of 1 if our mouse has collided with that object and 0 if it hasn't. So what we want to do is get a shortcut from our fan switch object, and we'll drag that down and connect it up to our detect mouse collision channel. So let's try this out already. Connect it straight up to the logic, and hopefully now as soon as our mouse cursor, let's go into the channel section and find our switch, and now let's see, as our mouse cursor goes over this object and we are in run mode, you should see that this turns from 1 to 0. So you see, yeah, that's working fine. Now at the moment you can only see this when we're in the editor. We can just see this value changing. So what we really want to do is give some kind of a visual indication that our mouse is over this and this switch is ready to work. So let's change its color from its standard color to red as soon as the mouse is over it. So what we can do for that is just take a shortcut from our detect mouse collision and bring that over to the material of our fan switch. So let's just make the red emissive and link that directly up to our detect mouse collision. So let's try the same thing again. You can see now it turns red as soon as our mouse is over it. We'll now look at disabling the camera's rotation. So the next thing we need to do is get this to work correctly with our walkthrough camera. Because you see, with our walkthrough camera at the moment, as we walk around, my mouse cursor is all over the place because I'm just using it to control the direction in which the camera is facing. As soon as I try and move my mouse towards our switch, the camera just rotates. So what we need to do is create some function that can disable the rotation of our walkthrough camera. So for instance, if we right click, then we can move the mouse freely around without rotating the camera. That would be ideal for this situation. So let's create that logic. If we go over to the group tree, over to the start group, and find our walkthrough camera, you can see here's its rotation vector. If we go inside here, you can see there's some pretty crazy stuff going on, but let's ignore that, because basically all we need to do here is affect the user input, which are these two things here, basically detecting the mouse X